What's poppin', dogs? Mr. Allen here. We're about to solve for x in these dope rational equations, and we're going to list any domain restrictions. Now, this first one here, x cannot equal 0. I don't want to divide by 0, so that is my domain restriction. You know what? I'll just jot that down. Can't equal 0, bro. Boom. All right, now I got to solve for x. Well, first I'm going to multiply both sides by x here, giving me, boom, those guys gone, 18 equals 2x squared. Now what I want to do, I'm going to divide by 2 on both sides, giving me 9 equals x squared. How in the heck do I solve for this? Ooh, I got a square root on both sides, giving me x equals, don't forget, plus or minus positive 3. That is not one of my domain restrictions, so we're good with both answers, and that is super dang dope. One more over here. Let's do it. I'm going to change colors. Here. Let's go with pink. All right. Wonderful. I thought I grabbed blue. It threw me off. Okay. Anyways, I got a fraction equals a fraction. This is the only scenario where you're allowed to cross multiply if you so choose. Some people are like, bro, don't say that word in math. Don't say cross multiply. I'm cool with it as long as you don't do it when you have addition, subtraction, multiplication, or division. It's only when a fraction equals a fraction that you can. Now, the mathematically correct way is I'm going to multiply by x plus 3 on both sides, right? That is gone. I got x plus 3 over here. And then I'm also going to be multiplying by x minus 7. So x minus 7 is going to get multiplied on both sides. I'm running out of room here, so I'm writing them in weird ways. But that's gone. Boom. And now what I have is 4 times x plus 3 equals negative 2x times x minus 7. Which is exactly what would happen if I cross multiplied, right? But again, we're multiplying each side by the denominators there because multiplication is going to undo the division of the x plus 3 and undo the division of that x minus 7, right? But hey, if we want to please the mathematicians out there, that's the way we do it, right? We don't say cross multiply. Anywho, off my soapbox or whatever I'm doing right now. I'm going to distribute this 4 in. I'm going to distribute this negative 2x in. And now I have 4x plus 3, 12. Woo! That was close. Equals, and we got negative 2x squared. And then we have plus 14x. All right. I got myself a quadratic here. Everybody seems to panic when they see quadratics not in the quadratic unit, and they forget everything about factoring to solve, right? Or quadratic formula in solving. They just start doing weird math they make up. I got to get everything to one side so that it's equal to 0, and I can use my zero product property, hopefully, to factor and solve this thing. I'm going to add 2x squared on both sides. I'm going to add subtract 14x, so that'll give me negative 10x plus that 12 that we have equals 0. Now, to make my life easier, I'm going to divide everything here by 2. And when I divide by 2 on both sides, I've got x squared minus 5x plus 6 equals 0. Right? I can divide by a constant and be all cool. I cannot, however, divide by an x or an x squared or anything involving an x because it would remove a potential solution from this problem. All right, so don't go through and remove x's. If you have a degree of 2 to start, you should have a degree of 2 later on. All right, so now I got to factor and solve this thing. What multiplies to 6 and adds to negative 5? That's going to be negative 2 and negative 3. Woo! Beautiful. So now I have x minus 2 equals 0, so x is going to equal 2. And I have x minus 3 equals 0, so x is going to equal 3. Now, I do need to check my original problem here for those domain restrictions that I did not write down at the very beginning. I'll do that in a different color here real quick. We're going to have domain restriction. That's going to be x cannot equal. Let's look at our original. I had x minus 7 up there, so it can't equal 7 because that would cause my denominator to be 0, thus dividing by 0, undefined, no bueno. And then over here, it's going to be negative 3. Does or do any of my solutions match those? No. So we are good with both of these solutions here. And there we have our domain restriction if the problem asks for it, which we did. And I almost forgot. I did have it in this one here, right? At the very beginning. All right. That's beautiful. That's fantastic and dope and awesome. And you know what? Like and subscribe, follow, all the different socials and things like that. And have a fantastic day, dogs.